Hello, let's solve another numerical problem from the portion ladder friction. Okay, here's the question. There's a uniform ladder which its length is 15 meter, which is again rests against a vertical wall, making an angle of 60 degree with the horizontal, and a coefficient of friction between wall and ladder is given, and between ground and ladder is given, and it says that a man weighing 500 Newton ascends the ladder. Then how long he will be able to go before the ladder slips? Then find the weight which is necessary to put at the bottom of the ladder so as to just sufficient to permit the man to go to the top. Assume the weight of the ladder as 850 Newton. Okay, so here two conditions is mentioned. That is, a person of 500 Newton, he is climbing up the ladder. Then before the ladder slips, how much distance he can cover? Okay, that is the first question. And the second question is, if we put some weight at the bottom of the ladder, okay, then we are putting a weight. You need to find out that particular weight which helps the man to go up the top of the ladder. Okay, so these two values we need to find out. First the distance, second one the weight which is required to put at the bottom portion in order to climb the person to the top. Okay, so first we will solve the distance part. Okay, so first we need to draw the free body diagram. Okay, so free body diagram, it's like this. There's a ladder which is slanting against the wall, which making an angle of 60 degree with the horizontal, and its total distance is 15 meter. Okay, 15 meter is the total distance. Here both the wall is rough, that is both the wall and as well as the floor has friction. Okay, so here we have a vertical reaction Ra, and when the ladder slips there will be friction, that is mu into Ra. This mu value is given as ground and ladder is 0.25, so this mu value is 0.25. Here also there is a reaction Rp. Also when the ladder slips there will be a friction. Okay, and this friction value is mu Rb, and this mu Rb here, it is the mu is 0.3. Alright, and they mentioned the weight of the ladder as 850 Newton. Okay, and a person is, so total is 15 meters, so it will be at the distance of 7.5 meters from the both end. And also a person is climbing, and it is 500 Newton. We don't know this distance, how much distance he can climb before the ladder slip, so we will put it as x. We don't know this position, so we just keep it as here as x distance. Okay, 500 Newton, we need to find this x distance. All right, for that, again, here also we need to consider our equilibrium equation. Sigma fx equal to 0, sigma fy equal to 0, and moment about a point is equal to 0. Alright. Okay, so first, I'm going to consider sigma fx equal to 0. You can start with any equation. Okay, so I'm just starting with sigma fx equal to 0. Sigma fx means sum of horizontal forces. So what are the horizontal forces here? First one is RB, which is in the right direction, so it is positive. Then minus mu into Ra, which is to the left, so it is minus. Mu value is 0.25, 0.25 into Ra is equal to 0. Okay, so from this equation I can write Ra as, I am giving Ra is equal to 4 times Rb. Okay, so I got Ra as 4 times Rb. Now I'm using the equation sigma Fy equal to 0. Sigma Fy equal to 0 means sum of vertical forces. What are the vertical forces here? I have Ra, then plus mu into Rb. Here mu value is 0.3, so I am giving 0.3 Rb. Then if 850 is downward, so minus, 500 is also downward, so minus, equal to 0. Okay, so I already know Ra as 4 Rb, so I am substituting this here and solving. I will get the value of Rb. You just need to substitute. Ra is 4 Rb plus 0.3 Rb is equal to 1350. From this I will get Rb as 313.95 Newton. Okay, so I got the value of Rb. Now I need to find out the distance x, right? For that I am using the equation, moment equation, that is moment about a point is equal to 0. So I am taking moment about this point. You can take any point, either A or B. I am taking moment about A. So moment about A means I need to consider all the forces and its moment about the point A. So first I am considering RB. RB is going like this. This is line of action and this is its perpendicular distance. Okay, this distance. And this distance is equal to how much? We know this side is 15 meter and this is 60 degrees. So we can, applying the trigonometric equation, we can find this side value, right? So it's equal to RB into 15 sine 60. Okay, this is making a clockwise movement at A. Now next is mu RB. Okay, this is also upward. This mu RB, its line of action is like this, and this is the perpendicular distance. Okay, so plus that is also making a clockwise movement there. So 0.3 RB into 15 cos 60. Okay, then we have a 500 Newton. It is going like this, and this is the perpendicular distance to A. So minus, this making an anti-clockwise moment at A. So minus 500 into x cos 60. So we are considering this small triangle. Now we have one more force. It is 800, right? 850. Minus 850 is also making an anti-clockwise moment at A. This is 850 is going like this. We need to find out this distance. And this distance is 850 into 7.5 cos 60 equal to 0. Okay, and solve this equation. We will get the value of x. RB we already know it is 313.95. Just substitute the value here, and from solving this equation we will get the value of x as 6.39 meter. That is, up to 6.39 meter the ladder is in equilibrium, that is don't slip. But if it cross the distance of 6.3 meter, the ladder starts to slip. Okay, so we got the value of x. Now our second part is that we now need to find out a particular weight which should hang at, or which can be placed at this point, this bottom point, so that the person can go up to the top. Okay, so this is our second part. That is, in second part our free body diagram will be like this. There's a wall and it is hanged against a wall, and we have a reaction here Ra and friction here mu into Ra. We have a reaction at here Rp and friction at here mu Rb, and total weight, that is 850. Then we need to put a weight here. Here is a weight, capital W, so that the person can go up to the top. So now the person is here. If he can go up to here, then what is the value of W? That we need to find. Alright, so total length is 50, angle here it is 60 degree. This is now condition, the present condition. We need to find the value of W. Okay, so mu here it is 0.25 and here it is 0.3 mu. Okay, so this is the condition. Here also what we have to do, we can apply the equilibrium equation. Sigma fx equal to 0, sigma fy equal to 0, and moment about a point equal to 0. Okay, so here also I am going to apply these three equation. So first I am going to, you can apply any equation. So I am here, I am going to start with the moment. Okay, so moment about A equal to 0. Okay, that is about this point I'm going to take moment. Like the previous one we did, we can consider from RB, that is RB into 15 sine 60. RB is going like this, and this is the perpendicular distance, makes an angle of, so make clockwise moment at A, so it is positive. Then plus mu into RB, that is 0.3 RB into 0.3 RB. This is the line of action of 0.3 RB. This is the perpendicular distance. 0.3 RB into 15 cos 60. Then we have a 500. Now this 500 is at the top. So minus 500 into, this is the 500. This is the perpendicular distance. 500 into 15 cos 60 minus the self weight 850 into 850 is acting at the center of the ladder, that is 7.5 meter from the bottom. So into 7.5 cos 60. This is 50. This is the perpendicular distance. Okay. is equal to 0. Solving this equation, I will get the value of RB as RB is equal to 455.205 Newton. Okay, from this I will get the value of RB. Now I am going to apply next equation, that is sigma Fx equal to 0. Sigma Fx means sum of horizontal forces. So what are the horizontal forces here? RB acting right direction minus mu RA, it is acting in the left direction. Mu means 0.25 into RA equal to 0. Okay, from this I can write RA as RA is equal to 4 times RB. Okay, now I am going to apply third equation, sigma Fy equal to 0. Sigma Fy equal to 0 means sum of vertical forces, that is RA, which is acting in perpendicular, upward direction, then plus mu RB, it is also acting in the upward direction. Mu is 0.3, this value, mu RB, 0.3 into RB. Then 500 acting downwards, 850 also acting downward, equal to 0. Okay. Sorry, one more here, it is, that is W. Okay, W is also there, so minus W equal to 0. Okay, so we need to find this W, right? Okay, so we can substitute either RA is equal to 4RB or RB is equal to RA is equal to 4RB or RB is equal to RA by 4. Anyway, we can substitute. So for RA, I am substituting 4RB plus 0.3 RB minus 1350 minus W equal to 0. We already know the value of RB, right? RB as 45.205. Okay, so substitute the value of RB here, and then by solving you get the value of W as 607.38 Newton. Okay, that is by putting a weight of 607 at the bottom point, the man with 500 Newton can climb up to the ladder.